grade 10. Welcome to Valenzuela Facebook Live, where science learning is truly amazing. So, how are you today? How did you spend your holidays? Well, due to pandemic that we are experiencing, the most awaited Christmas parties were prohibited. So, for the new normal, friends and families were gathered and celebrated Christmas and New Year through online video calls. Well, did you know that sending messages and online calls with your loved ones are application of science? Yes, thanks to science because we were able to connect with our friends anytime, anywhere. Thanks to electromagnetic waves. Actually, there are lots of human activities that we do every day that uses electromagnetic waves. But what is electromagnetic wave? Well, that is what we are going to find out in today's discussion entitled EM Possible. Today's mission are the following. First, define electromagnetic wave. Second mission, trace the development of electromagnetic wave. Third mission, describe the transmission and propagation of electromagnetic wave. Fourth mission, discuss properties of electromagnetic waves. Fifth mission, solve problems involving wavelength, frequency, and energy of electromagnetic wave. And last, compare the relative wavelength, frequency, and energies of different regions of electromagnetic waves. Are you ready to be an investigator for today? Great! So prepare your pen and paper and let's begin our mission, EM Possible. There are 5 significant scientists who contributed to the development of electromagnetic theory. They are Hans Christian Ørsted, James Clerk Maxwell, André Marie Ampere, Heinrich Rudolf Hertz, and Michael Faraday. At this point, I will give you your first mission. Your first mission is to know the contribution of the mentioned scientists to the development of electromagnetic wave theory. You will be given 5 seconds to key in your answer on the comment section. Are you now ready? So let's begin. First question. He showed how current carrying wire behaves like a magnet. 5 seconds starts now. All right, time is up. The correct answer is Hans Christian Ørsted. Danish physicist and chemist Hans Christian Ørsted discovered that electric current affects a compass needle and creates magnetic field. He was the first scientist to connect between electricity and magnetism. So let's have the next question. Question number 2. He demonstrated magnetic effect based on the direction of the current. Key in your answer. Your 5 seconds starts now. Time is up. The correct answer is André Marie Ampere. French physicist André Ampere found that wires carrying current produce forces on each other. Ampere's theory of electrodynamics states that 2 parallel portions of a circuit attracts one another if the currents in them are flowing in the same direction, and repel one another if the currents flow in the opposite direction. So let's have the next question. Question number 3. He formulated the principle behind electromagnetic induction? Who is that scientist? 5 seconds starts now. All right, time is up. The correct answer is Michael Faraday. Faraday describes how electric current produces a magnetic field, and conversely, how a changing magnetic field generates electric current in a conductor. Great job, students. Well, let's now have the next question. Fourth question. He contributed in developing equations that showed the relationship of electricity and magnetism. Who is that scientist? 5 seconds starts now. All right, time is up. The correct answer is James Clerk Maxwell. James Clerk Maxwell is a Scottish physicist and mathematician who studied the connection of magnetism and electricity, leading directly to the prediction of electromagnetic waves. Maxwell equations are used today as basis of electromagnetic theory. Good job, students. Now let's have the next question. Question number 5. He showed experimental evidence of electromagnetic waves and their link to light. Key in your answer. 5 seconds starts now. All right, time is up. The correct answer is Heinrich Hertz. Heinrich Hertz is a German physicist who showed that theory of electromagnetism was correct and the light and heat are electromagnetic radiations. He discovered that wave speed and wavelength can be measured, and wave speed is equal to the speed of light. The unit of frequency of waves measured in cycles per second was named after Heinrich Hertz in his honor. Great job, Agha investigator. Because of that, you will be given Agha medal for completing your first mission. So, what is electromagnetic wave? Well, take note that charged particles, such as electrons, produces electric field, and moving charged particles produces magnetic field. Again, charged particles, such as electrons, produces electric field, and moving charged particles produces magnetic field. Thus, a changing electric field induces magnetic field and vice versa. Therefore, electromagnetic wave or EM waves are waves that are created as a result of vibration between an electric field and a magnetic field. Always remember that electromagnetic waves are considered to be a transverse wave, meaning electric field and magnetic field are perpendicular to each other and to the direction of EM waves. Electromagnetic waves can travel through a vacuum, meaning EM waves can travel even without a medium. The term vacuum here is not pertaining to a tool that uses suction to clean. The vacuum that we are talking is defined as space devoid of air or matter. Well, example is the UV light from the sun. UV light is an example of electromagnetic wave. UV light travels from the outer space and reaches our planet even without a medium. Remember that EM waves travels at a constant speed equals to the speed of light, which is 3 times 10 raised to the power of 8 meters per second. Well, to better understand the EM waves, let's recall the different characteristics of waves that you need to remember. Are you ready for your next mission? Great. So your second mission is to identify the different characteristics of electromagnetic waves. You will be given 5 seconds to key in your answer on the comment section. Are you ready? Okay, so let's begin. Let's have question number 1. What do you call the maximum distance moved by a point on a wave, measured from its equilibrium position? Choices are amplitude, frequency, and wavelength. 5 seconds, go. All right, time is up. The correct answer is amplitude. Well, remember, amplitude is also known as height of the wave, which is measured in meters. Take note that amplitude of a wave is associated with the amount of energy it is carrying. Now let's have the next question. Question number 2. Which wave carries greater amount of energy? Is it A or B? 5 seconds, go. All right, time is up. The correct answer is B. Remember that the greater amplitude of a wave, the greater amount of energy it carries. So now, let's have the third question. What do you call the distance between 2 consecutive crests or 2 consecutive troughs? 5 seconds, go. Time is up. The correct answer is wavelength. Remember, wavelength is the distance between two consecutive crests or trough, and it is measured in meters. Now let's have the next question. Question number 4. What do you call the number of waves that pass a fixed point in a given amount of time? 5 seconds, go. All right, time is up. The correct answer is frequency. Well, frequency, the SI unit for wave frequency is hertz, named after Heinrich Hertz, where 1 hertz equals to the number of waves passing a fixed point in 1 second. Take note, a higher frequency wave has more energy than a lower frequency wave with the same amplitude. Now let's have this final question. Question number 5. Question number 5, which carries a higher energy? Or which wave carries a higher energy? Is it wave A or wave B? 5 seconds, go. All right, time is up. The correct answer is wave A. Now, remember that higher frequency wave carries higher energy. So, great job, students. Because of that, you will be given another AGHA medal for completing your second mission. All right. So, remember that wave's speed, frequency, wavelength are related by this equation. C is equals to F multiplied by lambda, where C is the wave speed or speed of light with a value of 3 times 10 raised to the power of 8 meters per second. F is frequency of the wave in hertz, and lambda, it is a Greek letter that represents wavelength of a wave, and it is expressed in meters. Now let us try to answer this problem using wave equation. Assume that the waves travel in a vacuum. Problem: what is the frequency of a radio wave with a wavelength of 20 meters? So first, let us identify the given. All right. So C is equals to, or the speed of light, the speed of wave is equals to 3 times 10 raised to the power of 8 meters per second. Remember, it is constant. Even if it is not given on the problem, the speed of EM wave is constant. And we have wavelength, which is 20 meters, and we are looking for the frequency of the wave. So this is our wave equation. C is equals to F multiplied by the wavelength, or frequency multiplied by wavelength. Now, since we are looking for frequency of the wave, we need to derive new equation from the original wave equation. So to get our new equation, or to get the frequency, we divide both sides by wavelength. Wavelength will be canceled. So our working formula, or our new formula, will be frequency is equal to the speed of light divided by the wavelength. Now let us substitute the given. Frequency is equal to the speed of light, 3 times 10 raised to the power of 8 meters per second, divided by the wavelength, 20 meters. Can you perform the operation? Key in the correct answer on the comment section. I'll be giving you 30 seconds to compute. All right, time is up. The correct key in your answer in the comment section. So the correct answer is 1.5 times 10 raised to the power of 7 hertz. All right, good job, student. You got it right. So it seems like you are now ready for your next mission. Your third mission is to compute for the frequency of a wave if the wavelength decreases from 20 meters to 15 meters. Again, compute the frequency of the wave if the wavelength decreases from 20 meters to 15 meters. You will be given 30 seconds to solve the frequency. Your timer starts now. All right, time is up. So the correct answer is 2 times 10 raised to the power of 7 hertz. So from the given example, we decrease the wavelength from 20 meters to 15 meters. And what happens to the frequency of the wave? So the wave, you are correct. The frequency of the wave increases. So great job, students. Because of that, the frequency of the wave increases. So because of that, you will be given another AGHA medal for a job well done on your third mission. All right, so there are different types of EM waves. And the different types of EM waves, or electromagnetic waves, are arranged according to their frequencies, wavelength, and energies. We call it electromagnetic spectrum. The different types of EM waves are the following: radio wave, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. Now study the diagram of electromagnetic spectrum. Can you describe how the wavelength, frequency, and energy of EM waves were arranged on the EM spectrum? All right. So we can see that from left to right of the spectrum, the wavelength of EM waves is decreasing. Take note that the shorter wavelength, the higher frequency, and the higher energy. So based on the spectrum, what type of EM wave has the highest amount of energy? You are right. Since gamma ray has the highest frequency, it also carries the highest amount of energy among all the EM waves. Now, which do you think has the lowest amount of energy among the electromagnetic waves? You are correct. The answer is radio wave. So radio wave has longer wavelength. Take note that longer wavelength, the lower the frequency and the lower the energy of a wave. Now, at this moment, I think you are ready for your fourth and final mission. So your final mission is entitled, What is the Order? Your mission is to compare the relative wavelengths, frequencies, and energies of the different regions of EM waves. You will be given 10 seconds to answer. Are you ready? All right, AGHA investigators, let's begin. Question number 1. Arrange the following according to increasing frequency. Again, arrange the following according to increasing frequency. X-ray, microwave, UV light. 10 seconds, go. All right, time is up. The correct order is microwave, UV light, and X-ray or X-ray. Good job, students. So let's have the next question. Arrange the following according to decreasing wavelength. Again, arrange the following according to decreasing wavelength. Infrared, radio wave, visible light. Key in your answer. 10 seconds, go. All right, time is up. The correct order is radio wave, infrared, and visible light. Good job, students. Let's have the third question. Arrange the following according to increasing energy. Microwave, gamma ray, infrared. 10 seconds, go. All right, time is up. The correct order is microwave, infrared, and gamma ray. Next question. Arrange the following according to decreasing frequency. Visible light, X-ray, radio waves. 10 seconds, go. All right, time is up. The correct order is X-ray, visible light, and radio wave. Now let's have the final question. Arrange the following according to increasing wavelength. Ultraviolet, microwave, and infrared. 10 seconds, go. All right, time is up. The correct order is ultraviolet, infrared, and microwave. All right, at this great job, students. Because of that, you will be given an AGHA medal for a job well done, and you will be given an Sai Henyo badge for completing all the mission. Now, at this moment, you are now free to write your questions on the comment section. All right, so I think the teacher moderator has already chosen questions from the comment section. So allow me to read. Next, so question number 1. Does the speed of EM waves changes if it travels in a medium? Again, question, does the speed of EM waves or electromagnetic waves changes if it travels in a medium? Well, remember that in a vacuum, the speed of EM wave is always constant, which is equals to the speed of light. But if EM waves travels in a medium, its speed changes and becomes slower. All right, so let's have the next question. Does visible light travels faster than a radio wave? So the correct answer, in a vacuum, radio wave and visible light travels at the same rate. It travels at the speed of light, which is equals to 3 times 10 raised to the power of 8 meters per second. So now let's have the third and the final question. Can we stop or block electromagnetic waves? The answer is yes. There are materials that can block or stop electromagnetic waves. Example is gamma ray. So we all know that gamma ray carries high amount of energy, and exposure to gamma radiation is harmful to us. Now, in Nuclear Research Institute, wherein they use gamma radiation on their experiments, they uses several inches of lead, concrete, or steel to stop gamma radiation from spreading to the surrounding. So I hope I have answered your questions. And for those questions that were not chosen, it will be entertained by your subject teachers on the follow-up discussion tomorrow. So this ends my presentation. Thank you for listening. Again, this is Ma'am Mylene saying, science is not boring, but science is fun and exciting. Have a good day and God bless.